These are the approximations for the cube root of 71 and 725. I arrived them in just a single step. Yet, the approximations are accurate to the second decimal place. Let me show you the simplest way to approximate the cube root of any number and explain the principles behind it. 71 is between 64 and 125. It's between 4 cubed and 5 cubed. 4 is the largest integer less than the cube root of 71. So the cube root of 71 is equal to 4 plus x. We'll express an approximate value for x as a fraction. The numerator is 71 minus 64. The denominator is 4 squared multiplied by 3. X is 7 over 48, approximately 0.14583. So the cube root of 71 is approximately 4.14583. What's the actual value? It's about 4.14081. The approximation is correct to the second decimal place. That's pretty accurate. Plus, the calculation process is super easy. Now, let's use this method to find the cube root of 725. Will it work well? 725 is between 512 and 729. It's between 8 cubed and 9 cubed. The cube root of 725 is 8 plus x. Let's calculate the fraction for the approximation of x. The numerator is 725 minus 512. The denominator is 8 squared multiplied by 3. X is approximately 1.10937. So the cube root of 725 is approximately 9.10937. What's the actual value? It's about 8.98351. There's a noticeable error. This method is not very suitable for approximating the cube root of 725. We need to find a more accurate method to reduce the error. To do that, let's explore the principle behind this method. The cube root of 71 is between 4 and 5, so we write it as 4 plus x. To find x, let's cube both sides. This gives a cubic equation for x. As x gets closer to 0, what happens to x squared and x cubed? If x equals 0.2, then x squared equals 0.04 and x cubed equals 0.008. If x equals 0.1, then x squared equals 0.01 and x cubed equals 0.001. As x approaches 0, x squared and x cubed approach 0 even faster. In this case, we can effectively treat x squared and x cubed as 0. So, we can simplify the equation by removing x squared and x cubed. This turns it into a linear equation. Solve the equation. X is this. The numerator is 71 minus 64. The denominator is 4 squared multiplied by 3. This is the same method introduced earlier, and it was accurate to the second decimal place. That's because the cube root of 71 is closer to 4 than 5. This method works well when the cube root is closer to the smaller integer. However, it didn't work well for the cube root of 725. The reason is simple. It is closer to 9 than 8. It's closer to the larger integer. In such cases, we need to adjust the method. The cube root of 725 is between 8 and 9, so it's 8 plus x. X is closer to 1 than 0. Cube both sides again. This gives a cubic equation for x. As x gets closer to 1, what happens to x squared and x cubed? If x equals 0.8, then x squared equals 0.64 and x cubed equals 0.512. If x equals 0.9, then x squared equals 0.81 and x cubed equals 0.729. As x approaches 1, x squared and x cubed get closer to x. So, in this case, we can treat x squared and x cubed as approximately x. Now, the equation transforms like this. The numerator of x is 725 minus 512. The denominator of x is 8 squared times 3 plus 8 times 3 plus 1. This denominator is larger than that of the first method. When calculated, x is 0.98156. So, the cube root of 725 is approximately 8.98156. How does this approximation compare to the actual value? Surprisingly, it's accurate to the second decimal place. The accuracy has improved. If the cube root of a lies between n and n plus 1, use one of the two formulas to approximate the cube root. If the cube root is closer to n, use the simpler formula. If the cube root is closer to n plus 1, use the slightly more complex formula. Good job!